So again, a sequence whose consecutive terms have a common difference is called an arithmetic sequence. So the common difference is 12. And so then, Adam, what did you get for the next three?
31, 43, and 55.
Good. All right. And letter B, Lydia, what did you get for the difference? How is it changing?
It's going down by 7.
Good. And we would say the common difference is minus 7. So, Emily, what were your next three terms?
R minus 7. Oh my gosh, sorry, this is 7 and R minus 6.
Yeah, R minus 6, because you have plus 1, so you subtract 7.
By accident.
Okay.
Okay then. So R minus 14.
13.
Okay.
And R minus 20. You're just off 1 on each of them.
Yeah.
That's okay. All right, now, if you remember to what we did in 9.1, and some of you got real frustrated, you're like, okay, it just seems like you're guessing. The good news is, with an arithmetic sequence, you don't have to guess. There's a formula, and it's a sub n is the nth term, a sub 1 represents the first term, n is the nth term, like is it the fourth term, the ninth term, and d is the common difference. I had a student several years ago who said, you know, because you have to memorize this and use it. And so to help him memorize it, he said, you know what, I think of DNA. If you just rearrange it a little bit, it's D times the n minus 1 plus a sub 1. And he kept saying DNA, DNA. So I stole that, that little suggestion. And it's really, really helpful. We'll do it the whole period as we work on this. An alternate form is a sub n plus 1 equals a sub n plus d. Let me go back up here. This one is referred to as an explicit formula. And what you mean by that is that I can find the 100th term. I can find the millionth term. And I don't have to find all the ones in front of it. This alternate formula is based on the recursive formula that I need to know the previous one. So if I know the 8th term and I know the common difference, I can find the 9th term. But if I'm at the first term and I know the common difference, using this I'd have to keep adding and adding and adding and adding. And that's a pain if you're going out to like 20 terms or more. Alright, so here we go. Example 2. You'll find this stuff's pretty straightforward. It says find the 68th term in this sequence. So I'm going to write down DNA. So it's a sub n equals d times the quantity n minus 1 plus a sub 1. And write the formula out every time. When you write it about 10 times in the notes, 10 times in the homework, you've got it memorized. No worries. So if I want to find the 68th term, a sub 68 represents the 68th term. What's my common difference here? How are the numbers changing? They're going down by 9. N is 68, and the first term is 16. So you can use your calculator here. This is negative 9 times 67 plus 16. So I'm getting that the 68th term is negative 587. Okay? In example 3, it says find the first term in the sequence for which a sub 31 is 197 and the common difference is 10. So I'm going to play the game. What do I know? I know I have DNA. That helps me find the nth term. Well, what's interesting is they gave us the 31st term. So I'm going to replace a sub n with 197, but that's really a sub 31. D is 10, so n is 31. And so when I play the game, what do I know? I plug everything in. The only thing unknown is a sub 1. So then you can begin to see why you solved these kinds of equations back in Algebra 1. You didn't know this is what was coming, but it was to prepare you. So I get 197 equals 300 plus a sub 1, subtract 300. and I get my first term, a sub 1, is negative 103. Okay? Now, in example 4, now that we're armed with this information, if we looked back on some of those sequences in 9.1, if they're arithmetic, we can use DNA to write the expression, so there's no guesswork. So it says find a formula for the nth term in an arithmetic sequence whose common difference is 3 and whose first term is 2. So I'm going to write down DNA. So a sub n equals d times the quantity n minus 1 plus a sub 1. So I'm looking for the nth term. That's a sub n. The difference is 3. We're going to leave n in there. So that's 3n minus 3 plus 2. So that's 3n minus 1. So there's your formula. Now, let's pause here a moment. And let's look back at one of the sequences we had in the previous section. If we had 1, 3, 5, 7, 9, and I think about DNA, the common difference is 2. The first term is 1. So we were doing some guess and check, and now we don't need to do that. It was 2n minus 1. Do you see that? So now it's like, okay, that frees us up that we don't need to guess. All right, this next one, I'm going to give you a head start on me. And it says, in example 5, the fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the first 5 terms of this sequence. So I want you to think a moment. Try a few things. Second period, they gave me 2 different ways to do it, and I gave them a third way. So there isn't just one way to do it. Anybody think they've got it? We're looking for the first 5 terms. Tyler, what do you think?
Is it 5, 10, 15, 20, and 25?
Mm-hmm. How'd you come up with it?
Well, I took a sub 13 65 and a sub 4 is 20. So that's a difference of 9. So I did 65 minus 20 divided by 9 to find the common difference, which was 5. And then I know the fourth term was 20, so then I did 5 more and then went 5 back for the ones before.
Awesome. Okay, do you see that? That between the 13th and the 4th term, that's 9 terms. And so 65 minus 20 is 45, so you can find, you're finding the common difference. The common difference is you're going up by 5, and so he just went backwards and went 15, 10, 5,
And then forwards.
and then you went forwards to get to the 25. So really you can do 65 minus 20 over 13 minus 4, and that will give you the common difference. Did anybody else get 5, 10, 15, 20, 25 and do it differently? Let me show you how I did it. Okay, I used the DNA, and of course I have to do it all algebra-ish. So I said, okay, if I have the fourth term is 20, I don't know the common difference, but it's the fourth term. So this is 20 equals 3D plus a sub 1. And I said, okay, I know the 13th term is 65. I don't know the difference. N is 13. Does anybody know where I'm headed with this? A system of equations. Nice. So this is giving me 65 equals 12d plus a sub 1. 20 equals 3d plus a sub 1. Huh, isn't that weird? In the last chapter, you solved systems of equations. Huh. That's so amazing. All right. So I'm going to multiply the bottom one by -1. And so I'm still getting, it really is doing what Tyler said. Okay, I'm getting 5. You can plug it in and find a sub 1, and there you go. So it was 5, 10, 15, 20, 25. But you can do it the way Tyler said. That's okay, because it's a common difference. All right, now example 6 says find the 9th term of the arithmetic sequence that begins with 2 and then 9. Okay, it's not 2 and 9, it's 2, then you get the 9. So let me give you a moment to try this one. Ask yourself, what do you know? What can I find? Now in this one, I'm writing down DNA. What's the common difference? They didn't come out and tell us, but we can figure it out, right? What is the common difference? 7. We're looking for the 9th term, and I know the first one. Hey, I have everything I needed. So it's 7 times 8 plus 2. 56 plus 2, we know is 58. Okay? So pretty easy stuff. All right, then we have the sum of a finite arithmetic sequence. If I want to add together all the terms in the sequence, I have a formula that says S sub n equals n over 2 times the quantity a sub 1 plus a sub n. So in example 7, it says find this sum. Well, I need to know how many terms there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm adding together 10 terms. So I want S sub 10. That's 10 over 2. The first term is 1, and the last term, or a sub 10, is 19. That's 5 times 20, which is 100. Okay, very simple. An arithmetic series is when you add together the terms in an arithmetic sequence. Okay, we talked about a series in the previous lesson. So it's just called an arithmetic series. And so there's an example on the left of an arithmetic sequence, and on the right is an arithmetic series. You're just adding those terms together. In example 8, it says find the sum of the 27 terms in this series. So I'm going to do S sub 27 is 27 over 2 times 14 plus negative 142. All right, so go ahead and do this on your calculators. And I got negative 1,728. Are you guys getting that? Okay, again, very simple stuff. In example 9, it says find the sum of the first 32 terms in this series. Negative 12, minus 6, minus 0, and so on. And I put a hint here because I don't know what the 32nd term is, but I have enough tools in my tool belt to find it. So the first thing I need to do is I need to find the 32nd term. Well, that's my DNA. What's my common difference here? It's going up 6, right? So it's a positive 6. 32 minus 1, and a sub 1 is negative 12. So you can use your calculators. and I got 174. So you need to know the 32nd term in order to add them up. So that's S sub 32 equals 32 over 2 times negative 12 plus 174. So make sure you can do the computation on your calculator. And I got 2,592. Okay? Any questions up to this point? Pretty straightforward. Alright, I'm going to give you a head start on example 10. It says an auditorium has 20 rows of seats. There are 20 rows in the first row, 21 seats in the second row, 22 seats in the third row, and so on. How many seats are there in all 20 rows? So I'm going to give you a moment to think about it. Ask yourself, what do you know? What do I need to find? Can I find it? And then do it, okay? So let me give you the head start. Are you getting 590 seats? Because you need to know how many seats are in the 20th row, right? So you do your DNA to that one. The common difference is 1. It's 20 minus 1 plus the first row had 20 seats. So there are 39 seats in the 20th row. Now I want to add them up. So I get 20 over 2 times 20 plus 39. So it's 590 seats. All right, last example. It says a small business sells $10,000 worth of products during its first year. The owner of the business has set a goal of increasing annual sales by $7,500 each year for 9 years. So you have the first year is set for $10,000, and then for 9 more years, for a total of 10 years, you're adding $7,500 the next 9 years. Assuming that this goal is met, find the total sales during the first 10 years this business is in operation. Again, I'm going to give you a head start on me, but you have to understand what are you being asked to find. Because second period, some of them got it wrong because they thought they were asked to do one thing when in fact it was something else. So let me give you a head start. Does anybody have field trip forms? Permission slips are due Wednesday, please. Okay, Wednesday. Try to bring it Monday, though. I got $437,000, $37,500. Okay, it did not say find the sales in the 10th year. It says during the first 10 years. So I had other students put down $77,500, and they only found out what the sales would be during the 10th year. Okay, do you guys understand that?